Okay, so my name is Bleris, and I'm a professor in bioengineering and the director of the synthetic biology lab in the, again, Department of Bioengineering. So our lab focuses extensively on genome editing technologies. Specifically, we focus on using CRISPR, which is the technology that received the Nobel Prize last year, to perform modifications on the genomes and correct, essentially, genetic diseases. What we do is we package CRISPR and CRISPR components, as you can see on the top right, in DNA vectors. We embed this in viruses, and we infect cells and rodents. And we can, in principle, make single nucleotide modifications in live animals at any desired location. It is an extremely powerful tool. Now, there are certain limitations. One of it is that sometimes CRISPR can create off-target effects. That is, it creates and introduces modifications or errors at locations other than the desired one. So what we really want is a tool that can deliver the CRISPR components, do the job, the editing, and then disappear. So we need a just-in-time solution. So what we did, and this is a perfect example of synthetic biology, we used DNA from 6 different species, as you can see on the top right. We put it on a vector, and we introduce a site at which CRISPR cuts on the vector itself. So it's a self-cleaving system, essentially. So it destroys, CRISPR does the editing on the genome, and it destroys itself. We introduced these modifications, we built this vector, we packaged it in viruses, we introduced it in cells, and we see on the top row how the signal, the payload, disappears after a little while, in contrast to the control, which stays constant. So we have a just-in-time solution to that genome editing problem. In other words, we have a message that is delivered in cells and will self-destruct. And you may recognize the actors on the top. Accordingly, our project was named Mission Impossible. And I think it was a prime example of how synthetic biology can be used to solve a real problem in genome editing and gene therapy. Thank you for your attention.